Hello, everybody. Um, Welcome back. It's been a while, but we're back. So, today we're going to do electric circuits. Um, this is question 10. Sometimes it will be question 9, it depends. So, a battery in the circuit diagram below has a negligible internal resistance and an EMF of 20 volts. So this question is in grade 11, grade 10 and 11. We don't have internal resistance. So the EMF, we use it as our external voltage or the total voltage of the circuit. So before we start answering the questions, we must remember these points first. So since we have series and parallel connected in the same circuit, we must remember that in parallel first, in parallel, we must remember that we have the voltage. Voltage is the same. Voltage is the same through the resistors. As long as the resistors are connected in parallel, they have the same voltage. But the current, on the other hand, current is divided. So the current is divided in the parallel, but the voltage is the same. So now let's talk about the series part. In series is the vice versa. Voltage is divided here. So in series, voltage is divided, but current is the same. So as long as you see the resistors in a series, just know that their voltage is divided. They don't have the same voltage, but they have the same current. The current flowing through the resistors in series, the resistors in series, they have the same current. So now we can go back to our question. So they said a battery in the circuit diagram below has negligible internal resistance and an EMF of 20 volts. So that 20 volt, we take it as our total voltage. So since we don't have internal resistance in this type of circuit, so we take the EMF as our total voltage, since the EMF is the maximum energy in the circuit. So now the reading on the ammeter is 4 amperes when the switch is closed. So when we analyze the diagram first, we see the ammeter here. That means this is the total current of the circuit. So we see 3.2 ohm resistor in series having the voltmeter V2, and when we move passing the ammeter, we see the resistors in parallel. So that means in this part current is divided, but they have the same voltage, which is V1. So that means resistor R and resistor 3 ohm resistor, they have the same voltage, which is V1, but the current is divided here. So that means this is what we're going to do. In 10.1 they said calculate the total resistance of the circuit. So the total resistance of the circuit, according to Ohm's law, we have this formula: R is equal to V over I. This is the Ohm's law. So since we are given the total voltage, which is 20 volts, and the total current, which is 4 ohm, that means we use the total voltage and the total current to get the total resistance. Because if we want to go through the circuit, we won't be able to get the total resistance because we have an unknown resistor. So we use the given information. So here, this one 10.1. We are looking for the total resistance. We use the total voltage, which is 20, divide the total current, which is 4. So 20 divided by 4, which is 5 ohm resistor. That means the total current, the total resistance of the circuit is a 5 ohm resistor. Now we move to 10.2. Calculate the reading on V1 when the switch is closed. So the switch is closed. Now we want to know the voltmeter in V1, the voltage in voltmeter V1. So how are we going to get the voltmeter in V1? 10.2, we check what's going on. V1, it is in parallel, yes, but we have the total current flowing through this. V1 is the voltage of R and 3 ohm resistor. So what are we going to do to get this one? We can use this one because this one, it is in series. That means since we said in series current is the same, that means the current that is flowing in 3.2 ohm resistor is the same current as this one. That means we have the 4 ohm, we have 4 amperes flowing here. That means we can use this one to get V2 first. So we can say V2 using the same formula. We cross multiply, that means it's IR. So by doing that, what is the current? The current is 4 because this one, it is in series. Current is the same. So we have 4. And then what is our R? Our R, we use 3.2. So this is 3.2. Then what is this? This gives us 12.8 volts. So since now V2 is 12.8 volts. This is our V2. Now we can get V1. How are we going to get V1? Since our total voltage is 20 volts, we have V2 as 12.8. That means getting V1, we have V1 is equals to total voltage, the V total, we call it V tot, minus V2. Because if we want the total voltage, that means it's going to be V1 plus V2. Now we are looking for V1. That means we take V total, we subtract V2. So what is V total? V total is 20 minus V2, which is 12.8. So what is that? That is 7.2 volts. So the voltage in V1 now is 7.2 volts. That was simple. Then now we move to 10.3. We must calculate the resistance of R. So how are we going to calculate the resistance of R? Let's divide this. Now this is what we're going to do. Let's check R first. R, it is in parallel. It is in parallel with 3 ohm resistor, and they have the voltage, which is V1. So let's say first we calculate the resistance in parallel first. So this one is 10.3. Let's say we calculate the resistance in parallel. So calculating the resistance in parallel, since we have 2 resistors in parallel, as long as there are 2, we can use this one. We are allowed to use this one. So Now, what is our R1? Our R1, we can take it as R2, or multiplication, sorry, 3 divide R plus 3. So, what is this? 3 times R, this is 3R. This one is R plus 3. So, now, we have the resistance in parallel now. So, that means now we can get V1. Now, how are we going to do that? We can see now Ohm's law R is equal to V over I. We're talking about the parallel part. Now, what is the total? What is the resistance in parallel? We have 3R over R plus 3 is equals to. Now, what is the voltage in V1? The voltage in V1 is 7,2. So, we're going to put 7,2 over. What is the current? The current is, this is the total current because they have the same current. That means now the parallel resistors now, this is the C, this is, we call them, now we name it one resistor. So now it's going to be 4 as the total current. That is the total current that is flowing in those parallel resistors. So now we cross multiply. Now we're going to get 4 times 3, this one is going to be 12R is equals to R times that one, that is 7,2R plus 7,2 times 3, that is going to be 21,6. So we group the like terms, we take this to the other side, it's going to be negative. Then 12 minus 7,2, that one's going to be 4,8 R is equals to 21,6. Then we divide by 4,8, divide by 4,8. Then our R is equals to 4,5 amperes. 4,5 ohm. So this is the resistance of resistor R. So let's move to the next question. Now, 10.4, they said calculate the current flowing through 3 ohm resistor when the switch is closed. The switch is still closed. Now we must calculate the current in 3 ohm resistor. Remember, this is the 3 ohm resistor with the voltage of 7,2 here. We got 7,2 volts. So it's easy. We have 10,2 or 10,4 or 10.4, sorry. So R is equals to V over I. Now, what is R? R is 3 because they're talking about the 3 ohm resistor. 3 ohm resistor is equals to the voltage in 3 ohm resistor, that is 7,2. Then we're looking for I. Then we cross multiply. This one's going to be 3I is equals to 7,2. Then we divide by 3, we divide by 3. Then I is equals to, this one will give us 2,4 amperes. So this is the current flowing through the 3 ohm resistor. So if they want to know the current flowing in resistor R, now it's easy to get it because the current is divided in parallel. That means we can take 4 as a total current. Then we subtract the 2,4. Then we can be able to get the current in resistor R. So okay, now we move to 10.5. Now we have 10.5. In 10.5, they said calculate the power dissipated by the 3,2 ohm resistor. Power. So let's check 3,2 ohm resistor. In 3,2 ohm resistor, we have the resistance as 3,2. We have the voltage as 12,7. We have the current, which is 4. So now we can go to our formula sheet. So in the formula sheet, we have the formulas for power. We have power, so also energy over change in time. We don't have energy, we don't have time. We're not given those. That means we're not going to use this formula. Now, power is equal to voltage multiplied by the current. This one, we can use it because we have the voltage, we have the current. Power is equal to current squared multiplied by resistance. That one, it can also work because we have the current, we have the resistance. This one, power is equal to voltage squared divided by R. Still, this one can work because we have the voltage and we have the resistance. So we can choose which one we're going to use. So I'm going to choose P is equal to VI. So what is V? V is the voltage, which is V2, which is 12,8, then multiplied by the current flowing in 3,2, which is 4, which is the total current. Now, what is the answer in here? This one is giving us 51,2. So this is power. The unit for power is watts. So make no mistakes when it comes to unit, because a wrong unit, it leads to a wrong answer. So the last question is 10.6. In 10.6 they said resistor R is removed. So now they are removing resistor R here in parallel. Will the reading on the ammeter increase, decrease, or remain the same? So this is how it works. In parallel, when we add more resistors in parallel, the total resistance decreases. That means the decrease in total resistance, it increases the current. But when we decrease or when we remove resistors in parallel, the total resistance of the circuit increases. And once the total resistance increases, according to Ohm's law, current is inversely proportional to current. That means, current is inversely proportional to the resistance. So once the resistance increases, that means the current decreases. So now they remove resistor R. That means now the whole circuit, it becomes the series. That means now the total resistance of the circuit now it's increasing. So once the total current or the total resistance increases, that means the current in the circuit will decrease. So the answer here is decrease. Just write decreases. Just like that. You just analyze the diagram first. We remove the resistor in parallel. That lead to the increase in resistance in the circuit. Once resistance increases, according to Ohm's law, I is equals to V over R. So once the resistance increases, the current will decrease.